Hi everybody, welcome to Mathematical Statistics, a review of set notation. In this video, I am going to talk about sets and set notation. The complete mathematical statistic course, we need some basic concepts of set theory. First, what is a set? Yes, a set is a collection of distinct objects. Collection of distinct objects. Example, set A, we use capital letters, then elements A1, A2, A3. So there are three elements here, A1, A2, A3. So again, A1, A2, A3 are called elements. Elements in A. We use capital letters like A, B, C to denote sets of points. And we use simple letters like A, B, C. We write down here A1, A2, A3. So we use simple letters to denote elements in a set. Elements in a set. And we use capital S to denote the set of all elements under consideration. Or S is called the universal set. Example, I write S 1, 2, 3, 4, 5, 6 and a set A 1, 3, 5 and set B 2, 4, 6. Here you see S has all elements of A and B. So S is the universal set. So then A has 3 elements and B also has 3 elements. So 3 is an element in A. So we can write down using notation 3 is in A or 3 is an element of A. And we can say 6 is not an element of A. So these are the notations for int. Then subset. Subset. For any two sets I call A and B, we will say that A is a subset of B, A is a subset of B, or we can say A is contained in B if every point in A is also in B. We use this notation to say subset. Mean A subset of B. A is a subset of B. Example, I use B 1, 2, 3, 4, 5, 6, the same example I used before, and A 2, 4, 6. So you see all elements of A 2, 4, 6 are in B. Therefore, we can say A is a subset of B. But if we consider like C, I write down 1, 3, 7. So you see 1 and 3 are in B, but 7 is not in B. Therefore, A is not a subset of C. Then let me explain Venn diagram. Sets and relationships between sets can be conveniently portrayed by using Venn diagrams. First, let me show you how to use Venn diagram to demonstrate this example, A and B set. So B is a big set, but we need the universal set. I say it is S. So now let me write down the universal set of this example. I say 1, 2, 3, 4, 5, 6. I use another extra one, number 7. So you see here, there are two sets, B and A. So I use B, this, and A is this. So this is A and this is B. Now first go with A because A is in B. Therefore first we fill set A. So 2, 4, 6. Therefore 2, 4, 6 in A. Now go to the B. Yes, B has 2, 4, 6. It is already in A. That means it is already in B. Therefore, we need actually 1. We need 1. 3. 3 is not here. Now 1, 3 and 5. Now consider the set elements of B are 1, 2, 3, 4, 5, 6. Yes. Now go to the universal set. Universal set has numbers from 1 to 7. And we see we have already numbers 1 to 6 in B. Then 7 is the only outside of the circle B. Therefore, we write down a 7 out of the circle B. Now you see A is a subset of B. So A is contained in B. Then the null set. The null, or we call empty set. Denoted by we use this notation or we use this notation. Is the set having no elements. So, null set is the set there are no any elements. It is just empty set. So, we use null set. This notation, null set is a subset of every set. Then the union. What is the union of set? Yes, the union of A and B denoted by A union B. So this is the notation we use to denote union. Is the set of all points in A and B or both. The set of all points in A and B or both. That is, the union of A and B contains all points that are in at least one of the sets. Let me write down. The union of A and B contains all points that are in at least one of the set. Let me show you using a Venn diagram. As usual, we have the universal set. So there are two sets, set A and set B. So this is A, this is B. According to the definition, union represents this area, this shaded area. This is the A union B. Let me explain this using an example. I use S 1, 2, 3, 4, 5, 6 and A I use 1, 3, 4, 6. Then I use B elements 2, 4, 5, 6. Then what is the A union B? A union B is all the elements of A and B or both A and B. So yes, we have 1 here and we can write 1. Then we have 2 in B. So we write 2, then 3 in A and 4 we have in the both in A and B. So we write just 1, 4 here because elements are not repeated in a set. Then 5 and 6. Actually here you see A union B is 1, 2, 3, 4, 5, 6. It is the same of S, but it is not the always. How do we use a Venn diagram for this example? So, we have S as usual, then we have A and we have B. So, first we go with the common elements. So, common elements are 4 and 6. So, I write 4 and 6 in this range because this is the common range, common area for both A and B. Then go to the A. We already have 1, 4 and 6, but we need 1 and 3. 1 and 3 only for A. Similarly, 4 and 6 are in B and we need 2 and 4. 4 and 6 are in B, we need 2 and 5. 2 and 5 are only in B. So outside we don't have any element except this. So 1, 2, 3, 4, 5, 6. So therefore no any elements of out of A and B. Then the intersection. The intersection of A and B we denoted by A intersection B. We use this notation. Or sometimes we use AB. Is the set of all points in both A and B. So I write down set of all points in both A and B. Let me draw a Venn diagram for this. So this is A, this is B. So common area for both A and B is this. So this is the A intersection B. As an example, I say S equal 1, 2, 3, 4, 5, 6 and A equal 3, 5, 6 and B equal 2, 3, 4, 6. So then what is the A intersection B? A intersection B is the common element of A and B. So you see 3, 3 and 6, 6. Therefore, common elements are 3 and 6. So we can write down. How do we draw a Venn diagram for this example? S and this is A, this is B. So what are the elements in A and B? First we go with this common element intersection part 3, 6. Then go to the A. A already have 3 and 6 but we need 5. It is only for A. And similarly 3 and 6 then we need 2 and 4 for only B. Now check with the universal set. We have already 1? No, actually 1 is not in S, so we need 1 outside of A and B. 2, 3, 4, 5, 6. Yes, the rest of elements are in A, B. That means that include in S. Therefore, this is the Venn diagram for this example. Then disjoint set. Or we call mutually exclusive. What is the meaning of disjoint or mutually exclusive? Suppose two sets A and B. Two sets A and B are said to be disjoint if they don't have common elements. That is, A intersection B should be what? It is empty. You can use this one or you can use this notation. Right. As an example, S equal 1, 2, 3, 4, 5, 6. A equal 1, 3, 5. B equal 2, 4, 6. So, you see any common elements of A and B? No. Therefore, A and B are disjoint, or we know A intersection B is empty. Therefore, A and B are disjoint or mutually exclusive. How do we use Venn diagram for this? So this is S. Actually, disjoint set like this. We have no common element, so no common area. So A is 1, 3, 5, B is 2, 4, 6. So actually no any elements of the outside. Therefore, this is the Venn diagram for this example. A intersection B union C equal A intersection B union A intersection C. I use this is A. Next one, A union B intersection C equal A union B intersection A union C. This is B. Let me verify this using a Venn diagram. So I use A. The first one, A intersection B union C. Let me explain this. So there are 3 sets. So again we need S and 3 sets. 3 circle A, B, C, A, B, C. So first, B union C. Let me consider this. B union C. So B union C is the all elements in B and C, or both B and C, right? So I can color these 2 circles B and C. And then we have A. Here A. So I color now A like this. That is the set A. Now go back to this and check this part. Because we consider this one set and this whole thing is the other set. Now we need the intersection of these 2 sets. If we consider the intersection, then we consider the area. We use every color for this. It means here we use white lines and I say yellow lines. So then both has in this area. You see? So this is the area A intersection B union C. This area. Right? So this area. Now let me consider the right side. Yes. So right side A intersection B union A intersection C. Alright. Let me check. So again we have the S and A, B, C. So first one A intersection B. So what is the A intersection B mean? That is the common area of A and B, right? Both A and B, common area is this. Both A and B. You got it? Yeah, that is this. So it is, I will use this. Okay, that is A intersection B. Now I use A intersection C. That means the common area of A and C. So what is the common area of A and C? This one. A and C. Right? So then go back to this notation, it is the union. If we use union between two sets, then consider the area, the whole area we colored, right? And in intersection, we consider the area we colored with each color, shaded area. This is the area we consider for the right side part. Therefore, you see red color, the area of red in the both Venn diagrams are the same. That means the A intersection B union C equal A intersection B union A intersection C is correct. This you can try the next one, B, second one by yourself. Then the Morgan's laws. It is A intersection B, this is complement, equal A complement union B complement, and other one A union B complement equal A complement intersection B complement. Let me verify this using a Venn diagram. Actually, I will prove this one. So, there are two sets. Therefore, we need only A and B. As usual, this is S. So, first one is this part is A intersection B complement. What is the meaning of that? A intersection B is this. You know that is the A intersection B. But we consider complement, therefore we consider whole area but intersection. So I color this. Everywhere but not intersection. You see that. Right. Now next one, I use A bar complement union B complement. So actually this is A intersection B complement. So this case, again we need two sets A and B. So this is S. So first A complement. So what is the A complement? It means everywhere but not in A, right? So I use everywhere but not in A. This one. Then I use B complement. What is the B complement? It is everywhere but not in B, right? So I use blue color everywhere but not in B this way. I change this on this. Right. So now what we do, we go back to this, the notation in between these two sets, it is a union. Again, as I mentioned before, union is the area we use colors. Maybe one color, maybe all colors, right? So then you see we have empty part is this, the middle part, right? So then you consider these two both has the same area, shaded area. That means the first one, A intersection B complement equal A complement union B complement is true. So that